I want to start off with calculated columns because they're a bit more user-friendly, a bit more intuitive, and easier to understand because you can actually see the results of each row of the table. So, simply put, calculated columns allow you to add new formula-based columns to the tables in your Power BI data model. And there are a couple of important things to note here. Number one, there's no A1 style references. You can't point to cell D16 or B5. Calculated columns refer to entire tables or columns. Next, calculated columns actually generate new values for each row in the table, and those values are visible within the tables within your data view in Power BI. And third, calculated columns understand something called row context. And what I mean by that is they can see the information contained within each row in which they calculate. And so they're great for defining things like properties based on information within that row. But they're generally useless for things like aggregation, like sums or counts or averages. So an important note here, as a rule of thumb, you're going to want to use calculated columns if you want to stamp static fixed values on each row within your table. Remember that you can also head upstream from here and use the query editor to add calculated columns. But what you don't want to do is use calculated columns for aggregation formulas or try to calculate numerical values to use in value areas of a visualization. So we'll be using measures for that instead. Pro tip here, calculated columns are typically used for filtering data, giving you new fields that you can use to create those filters, rather than creating or defining new numerical values. Alright, so let's walk through a couple of quick examples. Here we've got two different tables, and in each case we've created a new calculated column. In the top, one for parent, and then in the bottom right, one for total quantity. Now, in the top left example, you'll notice that in the DAX formula bar above the table preview, that we've created a new column that we've named parent, which equals yes if the total children field in that table is greater than 0, otherwise return a no. And when you read through this formula, you'll notice that it looks very, very similar to what you might write in Excel. So it's that same kind of user-friendly syntax. Now remember, since this calculated column understands row context, a new value is calculated in each row based on the associated value in the total children column. So what we're doing here is cycling row by row by row through the table, and we're looking at the row context for the total children column and returning the proper value based on how we've defined our formula. So this is a valid use of calculated columns. It creates a new row property that we can now use to filter or segment any related data within the model. So we can grab that parent field, pull it into a visual, and break down our numerical metrics or values to compare data for parents versus non-parents. In the second example here, we're actually trying to use an aggregation function. In this case, a simple sum of the order quantity field to create a new column named total quantity. But here's the thing. Since calculated columns don't understand filter context, and we'll get into that a bit more later, the same grand total is returned for every single row of the table. So it doesn't matter which row you're in. When you're calculating the value in row 1 or 2 or 3 or 4, in every single case, the sum of the order quantity field is the same sum. It's the same exact total. So because of this, it's not a valid use for calculated columns. We've essentially just taken that grand total and stamped it into every single row in the table. And in doing this, we've created this static column of numbers that can't be filtered or sliced or subdivided in any way. So for cases like this, can you guess how we're going to handle it? That's right, we're going to be using measures, the other important application of data analysis expressions. So let's quickly hop into our Power BI file and we'll run through a quick demo of this ourselves. Alright, so once you've opened your AdventureWorks report, we're actually going to head over to our data view here and make sure you've selected the sales data table, right? And what we want to do is we want to create a calculated column based on the order quantity column here. And if you remember earlier when we created the conditional column within the Power Query editor that was called quantity type, right? That was based on this order quantity column. We want to recreate that, but this time using DAX. So there's a couple of different ways that we can do that. Right? We could right click the column and we could create new column from here or from anywhere within the table. right? You've got these contextual menus, right? We've got these table tools here. When we click on the column, we get some column tools here. So again, we can create a new column from a variety of different locations. Again, that's a very common theme that you'll continue to see throughout Power BI as you use it, that you can do the same thing from multiple locations. So we're going to create a new column, and we're going to call this quantity type equals, and this is going to be using an if statement. So what we want to say here is that if our order quantity column is greater than 1, then we're going to return multiple items, otherwise a single item. As a best practice here, it's great to also format your DAX. So I like to follow this DAX IntelliSense, right? And you can see here, as soon as we entered in our if statement, we get the different conditions, right? Or the different parts of our if statement. So we have our logical test, then we add in a comma for our result if true, and then a comma for the result if false. And in order to follow this and kind of break out these different conditions for each one of these functions, if you hold down Shift and hit Enter, you're going to return down a line. Again, this is a great way to be able to visually break out and see the different components of each of the functions. This is really more important as you start nesting functions together. That way you can really see how it's all working and flowing together there. So our logical test here is going to be based on the order quantity column, right? So we want to say our sales data order quantity column, when that is greater than 1, we want to return multiple items. If it's not greater than 1, we want to return single item. And then we'll close our parenthesis there. So really straightforward here, right? So let's lock this in, right? And you can see we've got this quantity type column that's now created. Single item, order quantity equals 1. Now let's take a look at only our multiple items. Multiple items, order quantity is 2, or higher there. So again, that works exactly the same way that it does when you created that column within the Power Query editor. This time we're just using DAX. So now if we were to add another calculated column here, and we're going to call this something like total quantity, and let's use one of our aggregation functions like sum. Again, Shift Enter to return down a line. And let's say we wanted to sum the order quantity column from our sales data table, right? And we close our parentheses, hit Enter to lock this in. And now look what happens, right? Same thing that we saw in the slides. We get the same repeating total for each and every row here, because there's no row context when you're using an aggregation function to create a calculated column like this. So this is not a valid use of a calculated column. So we're going to go back and we'll right click, delete, confirm that we want to delete that. And instead of using a calculated column for that type of an aggregation, this is really something that we want to use a DAX measure for, which is what we're going to dig into next.